We're starting adding, subtracting, and multiplying radical expressions. The most famous radical is the square root. Now, we can also have cubed root or fourth roots and some of those, but most of the time we're dealing with square roots. Then we're also going to rationalize denominators. So, some rules when we are talking about adding and subtracting and multiplying. This is very important. Rules in the previous section allowed us to split radicals that had a radicand, which was a product or quotient. Product means multiply. Quotient means divide. And we can split things then. However, we cannot split them when we are adding and subtracting. So the square root of a plus b is not equal to the square root of a plus the square root of b. You cannot rewrite it like that. In the same way that x plus 2 squared does not mean, it does not mean x squared plus 4. It's the same idea, So just like we could not do x squared plus 4 when we've got x plus 2 squared, we cannot do the square root of a plus the square root of b when we have the square root of a plus b. The same is true for subtraction. So we have to remember this. This right here is not allowed. So square root of a plus square root of b, square root of a minus square root of b is not allowed if we start with both of them under the radical. You have to leave it under the radical. Okay. So, like radicals are radicals with the same index and the same radicand. That means if I've got the square root of 4, well, let's not use 4, let's use 3, plus 2 on the square root of 3, that means I have the same number here. Now, these are square roots, so we don't have our 2 there, because it's square root, and the number inside the square root must be the same. So the number 3 inside and what is right here has to be the same. Then we treat them the same way that we would treat variables. So this is similar to x plus 2x. And what is x plus 2x? 3x. So this right here is going to be 3 on the square root of 3. So that is how our radicals work for adding and subtracting. Like radicals are radicals with the same index and the same radicand. Like radicals can also be combined with using addition or subtraction by using the distributive property. So we're going to look at some of these. Is it okay to move off the screen? So here we go. We're going to treat square root of 3 the same way we would treat 1 on the square root of 3. So I've got 1 on the square root of 3 plus 7 on the square root of 3. So 1 plus 7 is 8, and then I keep the square root of 3. I don't do anything with the square root of 3. It's like a variable. Think of it the same way that we think about x. I don't like how I wrote that. Let me write the 3 a little bit. There we go. So 1 on the square root of 3 plus 7 on the square root of 3 is 8 on the square root of 3. Square root of 3 stays the same. Just like we would a variable. We keep it. Here I've got 10 on the square root of 2 minus 4 on the square root of 2. So what's that going to give us? 6 on the square root of 2. So here I've got square root of 2, square root of 2, and square root of 2. I'm not multiplying. I'm treating that like I would treat adding and subtracting variables. Okay, now let's look at this next one right here. The index here is 2. Okay, that means we're taking the square root of both of those. But is the number the same on the inside? No, it's not the same. So this right here cannot be simplified. That's as simple as it can go. Okay, cannot be simplified further.
So in this case, when we write cannot be simplified or square root of 5 plus square root of 3?
Either is fine. Either is fine. Okay? Now I want you to look at the next one. Here I've got square root of 2, but here I've got cubed root of 2. So our number here is the same inside the radical, but this is 2 and this is 3. So these are different. So that means cannot be simplified. So that is as simple as it goes. So this also cannot be simplified. Okay? Okay, and so we're going to spend the next 30 minutes or so talking about these types of problems and when we can simplify and when we can't simplify. Okay? That's what we're looking at. Okay, so let's get started. Sometimes we have to simplify the radical first. So the first thing that I'm going to do here is I am going to simplify the square root of 27. Is there a perfect square factor for 27?
I mean,
9, okay? 9 is a perfect square factor. So the square root of 27 breaks down to 9 times 3. 27 is not a perfect square, but there is a perfect square factor of 27, and that's what we want. What's the square root of 9? Good. So then I rewrite this as 3 on the square root of 3. Now, if you remember, if you aren't sure how to do this with perfect square factors, we do our factor tree. So I've got 27. 27 breaks down to 3 and 9. And then 9 breaks down to 3 and 3. So then I can write 3 times 3 times 3 on the outside. I'm looking for a set of 2. A set of 2. Okay? And since I've got a set of 2 there, I bring 1 out. And I get 3 on the square root of 3. You can do this either way. Okay? What about 75? Sorry.
25.
Good. My perfect square factor here is 25. So 75 breaks down to 25 times what? 3, and the square root of 25 is 5. Okay? So then I have 5 on the square root of 3. Okay? Now, these are like terms. These are like terms. So what's 3 on the square root of 3 plus 5 on the square root of 3?
8 on the square root of 3.
Good. 8 on the square root of 3. And that is my final answer right here. Okay. Can I go to the next screen? We got it? Okay. So I've got 3 on the square root of 20. Is there a perfect square factor in 20? 4. So I'm going to keep my 3 on the outside. I'm going to rewrite 20 as 4 times 5. The square root of 4 is 2. So I've got a 3 on the outside. Then I've taken the square root of 4, so it's on the outside. And then I've got a 5 that's left on the inside. I can multiply 3 times 2 together. What is 3 times 2? Good. So I have 6 on the square root of 5. Okay. Now I'm going to go ahead and bring down my minus. Okay. So now let's do 7 on the square root of 45. Is there a perfect square factor in 45?
No.
Good, it's 9. So I have 7 on the square root of 9 times 5. What's the square root of 9? Good. I keep the 7 on the outside. Now I've got a 3 on the outside because that's the square root of 9. And then I've got a 5 left. And I multiply that 7 and 3 together. So then I have 21 on the square root of 5. Okay. I am subtracting. You think of the square root of 5 the same way that you would think about a variable. Okay. So I'm going to subtract the 6 and the negative 21. That's going to give me negative 15. And then I keep my square root of 5. Okay. And this right here is our final answer right here. Okay. So now, what is on the outside of this one right here? Negative, and we can think of that as negative 1. Okay, we can think about that as negative 1 on the square root of 75 plus the square root of 12 minus 3 on the square root of 3. Okay, so that negative 1 right there, you can think of it that way. So now I'm going to deal with my 75. Okay. So I've got negative 1 on the square root of 75. We already know one of the perfect square factors in 75. Did you get all 3? Okay. Okay, what's the perfect square factor in 75? Good. So we're going to have 25 times 3. Okay, square root of 25 is? Good. So I'm going to have negative 1 times 5. I keep that negative 1 on the outside, and then once I pull the 5 out, I'm multiplying. So I have negative 5 on the square root of 3. Okay. Now I'm going to do the square root of 12. Is there a perfect square factor in 12? Good. 4 times 3. Okay. Square root of 4 is 2. So I'm going to have 2 on the square root of 3. Okay, and then my last one is negative 3 on the square root of 3. Can that be broken down anymore? No. Nope. So I'm just going to have minus 3 on the square root of 3. Now, every one of these is square root of 3. So all I have to do now is add their coefficients together. Okay? So negative 5 plus 2, negative 3. Negative, excellent, negative 6, and it's going to be on the square root of 3. Negative 6 on the square root of 3, and that is my final answer right here. Okay, as long as you practice these, you're going to be fine. Okay, typically students do better on the 4th test in the final exam than they do on the 3rd test. The 3rd test is kind of the one that's icky. 3rd test is icky. Okay? Now, is it okay to move to the next one? Okay, now we're going to bring variables in. Okay, we're going to do this the same exact way. We just have variables. So I'm going to start with 3 on the square root of 45x cubed. 45x cubed. So I have 3 on the square root of 45x cubed Let's focus on the 45 first. Let's focus on the 45 first. What is a perfect square factor inside 45?
9 times 5.
Good. So 9 is my perfect square factor. So then I have 9 times 5, and that's my 45. Now, x cubed is not a perfect square. Okay, x cubed is not a perfect square. But x to what power is a perfect square? Good. So I am going to rewrite my x cubed as x squared times x to the first. Is x squared times x to the first the same thing as x cubed? It is. So now I can take the square root of 9 and I can take the square root of x squared. Okay, I keep my 3 on the outside. What's the square root of 9? Good. And what's the square root of x squared? Good. And then I am left with 5x on the inside. 3 times x. It's going to be 9x. Notice that's on the outside. Then I'm left with 5x on the inside. Okay. Now, let's look at this one closely. All of this has to be exactly the same. Okay? The variable here has to be exactly the same. They both have to be square root, and what's inside the square root has to be exactly the same to combine those. Now, what number is in front of this one right here? Good. So there is a 1 right here. So 9 plus 1 is 10, and then my term is exactly the same. So this right here is my final answer. Okay. Now these are a little bit different. Okay? What's different about these?
Not the same inside.
They're not the same inside, and it's cubed. That's the big thing that's different, is they are cubed. Okay? I've got cubed right here. So I am no longer looking for a perfect square factor. I have to look for a perfect cube factor, and we don't pick up on those as easily. We don't know those as well. So when we get to cubes, I always recommend doing the prime factorization. Okay? 64 is even, so what number goes into it? 2. So that's going to be 2 times 32. 32 is even, so what goes into it? Good. 16's even. Good. 8's even. And 4's even. So we got a whole bunch of 2's, don't we? Okay. So what I'm going to do is I'm going to rewrite this 64. And I've got 2 times 2 times 2 times 2 times 2 times 2. Okay? And so that's what I'm going to write down. You could either write down 2 to the 6th, or you could write down 2 times 2 times 2 times 2 times 2 times 2. And because of this number right here, I'm looking for a set of how many? 3. So here's a set of 3, and here's a set of 3. So I'm going to bring out a 2, and then I'm going to bring out another 2. Is there anything left inside? No. So what is the cubed root of 64? It's 4. And you might remember that, okay? Sometimes we remember 8. Every once in a while we remember 27. Once we get any higher than 3 cubed, we don't typically remember. So it's better to write them all out, okay? Now, 14 breaks down to 2 times 7. Can I break that down any more? No. So I just have to leave that as the cubed root of 14. I can't do anything else there. And then I've got minus 9. 4 and negative 9 are like terms. That gives me negative 5 plus the cubed root of 14. Now, you cannot go any further. This right here is as simplified as it can be. That's my final answer. Right here. I can't do anything else. Okay? Because this, it doesn't have a perfect cube in it. Okay. Gonna go to the next screen. Okay, here we go. I got the square root of 45 over 4 minus square root of 5 over 3. These are, we got several different things going on here. We are adding and subtracting fractions with unlike denominators. Okay, so we're going to deal with that first. So I have a 4 and I have a 3. What's going to be my LCD if I've got 4 and 3? Good, it's going to be 12. So I'm going to have something over 12 minus something over 12. 4 goes into 12 how many times? 3. So I'm going to have to multiply my numerator by 3 also. So I'm going to have 3 on the square root of 45. Okay? How many times does 3 go into 12? Good. So I'm going to multiply the 3 times 4. If I multiply 3 times 4, I've got to multiply the square root of 5 times 4. Now, this 4 is on the outside of a square root. This 5 is on the inside of the square root. So I can't multiply that 5 with that 4 and get 20. Where does this 4 go? In front. Good. So I get 4 on the square root of 5. Okay, so now I've got 3 on the square root of 45 minus 4 on the square root of 5 over 12. These are not like terms. I cannot simplify them yet. Can I simplify this right here? I can. So I've got 3 on the square root of 45. 45 breaks down into a perfect square. 9 is that perfect square. Okay, so 9 times 5 equals 45. What's the square root of 9? 3. So then I have 3 times 3 on the square root of 5. What's 3 times 3? Good. Okay, so now I've got 9 on the square root of 45 minus 4 on the square root of 5 over 12. Whoops, I made a mistake. Let's back up. I have 9 on the square root of what? 5. Minus 4 on the square root of 5 over 12. Now, can these be combined? Yes. So my final answer to this is going to be 5 on the square root of 5 over 12. That's my final answer. Now, I just want you to be aware that if this right here and this right here could simplify, then you would. Okay? If those two can simplify. So if this was a 4 instead of a 5, then you could cancel that out. Okay? Okay. So, we're about to move into multiplication using the distributive property in FOIL. Any questions on simplifying? We doing okay on simplifying? Okay? Okay. Now, I want you to think of this right here the same way we would think of 2 times x minus 3. Okay, what would I do with this 2 right here? I would distribute it. 2 times x is 2x. 2 times -3 is -6. I would distribute it. Okay, we're going to do exactly the same thing here. We are going to distribute this square root of 3 to both terms in my binomial. Now, I am going to write this out so that you can see exactly what's happening here, and I would encourage you to write these out. Okay? So I've got the square root of 3 times the square root of 3. So that's my first distribution right there. I'm going to keep the minus. Then I've got square root of 3 times the square root of 2. Okay, now, square root of 3 times square root of 3. What is the square root of 3 times the square root of 3?
Would that just be 3?
It is 3. Okay, square root of 3 times square root of 3 is 3. And let's think about why. So if I've got square root of 3 times the square root of 3, that's the square root of what? 9. And I'm allowed to do that because this is multiplication. If it was addition, I couldn't do it. Because it's multiplication, I can. Okay, that's like what we did last Thursday. So square root of 3 times square root of 3 is square root of 9. And the square root of 9 is 3. So square root of 3 times the square root of 3 is 3. Now, these are both inside the radical, and they're being multiplied. So because it's multiplication and not addition or subtraction, and because they're both inside, then I can multiply those together. What is square root of 3 times square root of 2? It is square root of 6. Okay? So this right here is my final answer. Okay? That's my final answer. Now, for the next one, we have to FOIL. For the next one, we have to FOIL. So I have square root of 3 minus 8 times the square root of 3 plus 8. And I'm going to write this out. Write down every step. So I've got the square root of 3 times the square root of 3. That's my first terms. Okay. Then my outer is square root of 3 times positive 8. My inner is negative 8 times square root of 3. And then my last are negative 8 times 8. Okay? So, right here, I'm only focused on this part right here. What is square root of 3 times square root of 3? 3. Okay? Now, right here, I've got square root of 3, and then I've got an 8. My 8 is outside the radical, so it has to stay outside. The 3 is inside the radical, so it has to stay inside. So all I can do here is rewrite this as 8 on the square root of 3. Okay? Same thing here. My negative 8 is on the outside, and my 3 is on the inside. So I can't multiply those together and get 24. My negative 8 has to stay on the outside. My square root of 3 has to stay inside the radical. So this becomes minus 8 on the square root of 3. Okay? I can multiply negative 8 and 8 together because they're both on the outside. What's negative 8 times 8? Good. Okay? Now, let's look at these two terms right here. What happens there?
Cancel.
They cancel. So I'm going to have 3 minus 64. These cancel because one's positive and one's negative. So my final answer here is going to be negative 61. Now, in just a minute, we're going to talk more about this right here. Okay, in just a minute. These are called conjugates. Conjugates. Okay, these are called conjugates. And because they are the same, and one's plus and one's minus, that's going to be the difference of perfect squares, and that's when the middle two terms cancel out. And that's going to be super important when we start rationalizing. Okay, now, my next problem is more challenging. So you're going to have to hang with me on my next problem, okay? Okay, can I move off this one? Okay. I want you to think about this part right here as a single unit. You are going to think about the square root of x plus 1 as a single unit. I can't separate that at all. So don't think of this as 3 terms. Think of this as 2 terms. Okay? That's what you're thinking about this. This is 2 terms. The square root of x plus 1 is a single unit. Okay? I'm going to rewrite this because I'm squaring it. So we are squaring a binomial. That's what we're doing here. Squaring a binomial. So I've got the square root of x plus 1, which is a single unit, plus 2 times the square root of x plus 1 plus 2. Okay, and remember, we are thinking about this as a single term. A single term. So when I do first, this is my first term, and this is my first term. So that's going to be the square root of x plus 1 times the square root of x plus 1. That is my first. Then for outer, I'm going to have the square root of x plus 1 times 2. Okay, so I've got the square root of x plus 1 times 2. My inner is 2 times the square root of x plus 1. Okay. And then my last is 2 times 2. Now, we are going to focus on this right here for just a minute. I'm going to focus on that right there for just a minute. So what I have is I have the square root of x plus 1 times the square root of x plus 1. Now, I can put that in parentheses. Because they are both inside the parentheses, and they are under the radical, and being multiplied, I can rewrite that as x plus 1, x plus 1. Okay? That's because they're being multiplied, they're not being added, and they're both under the radical. Now, I can rewrite this as x plus 1 squared. And what is the square root of x plus 1 squared? X plus 1. Okay? And think back to when we just multiplied the square root of 3 times the square root of 3. What was our answer? 3. Okay? So what I've got right here is I've got the square root of x plus 1 times the square root of x plus 1. So our answer, when I multiply those, is just what's inside the radical without the radical. Okay, so when I multiply those two together, they're exactly the same. So I remove the radical. Okay, now here, I've got 2 that's on the outside times the square root of x plus 1 that's on the inside. So I can't do anything with that except multiply 2 on the square root of x plus 1. So really there, all I've done is change the order. Then I've got 2 on the square root of x plus 1. Okay. And what's 2 times 2? Good. Okay. This and this are like terms. So I've got 5. Do I have anything I can combine the x with? No. Okay. What about 2 on the square root of x plus 1 and 2 on the square root of x plus 1. Are those like terms? Yes, it's going to be 4 on the square root of x plus 1. Now, if you had x written first, you're fine. So if you had x plus 5 plus 4 on the square root of x plus 1, that's okay. That is not a problem at all. And so this right here is our final answer right here. Okay, that's your final answer. Okay, now we're going to move into rationalizing the denominator. Rationalizing the denominator. And this is something that you do in algebra quite a bit. You'll do that in 112 and you'll do it in 113. Those of you that are taking 112 and 113. So let's talk about rationalizing the denominator. Can I move off this? We got it? Okay. Rationalizing the denominator. Many times it's helpful to rewrite a radical quotient with the radical confined to only the numerator. If we rewrite the expression so that there is no radical in the denominator, it is called rationalizing the numerator. This process involves multiplying the quotient by a form of 1 that will eliminate the radical in the denominator. Now, there is such a thing as rationalizing the numerator. It's one technique that you use in calculus when you're trying to find limits. So if any of you are headed to calculus, that will be something that you touch on when you are trying to find limits in calculus. But most of the time what you focus on is rationalizing the denominator. Something's not truly simplified unless there is no radical in the denominator. Okay? So let's get started on this. So what I have right here is I have the square root of 3 over the square root of 2. So what I want to do here is I want to get rid of that square root of 2 in the denominator. So it's okay to have 2 in the denominator. What I don't want is the square root. So I want to get rid of square root in denominator. That's what I want to do. That's how I rationalize a denominator. Now, what is it that I can multiply the square root of 2 by to make it 2? What can I multiply the square root of 2 by to make it just 2? Correct. So if I multiply the denominator by the square root of 2, what do I have to do to the numerator? Same thing. So square root of 2 times the square root of 2 is 2. So this right here gives me 2 in the denominator. Okay? Now, square root of 3 is inside a radical and square root of 2 is inside the radical. So since they're both inside and it's multiplication, can I multiply them? I can. So that's going to be square root of what? 6. Now, I cannot simplify anything because this 6 is in the inside of a radical and this 2 is in the outside. To simplify, they both have to be inside or they both have to be outside. I can't simplify if one's inside the radical and one's outside the radical. So I can't simplify this any further. This is it. I've got to stop right here. That's my final answer. Okay? Okay. Can I go to the next screen? Okay. Now, you can do this one a couple of different ways. My advice is to simplify this first. Okay? I would simplify the square root of 45x first. Because we know there's a perfect square factor in there. What is the perfect square factor in there? What's the first square factor? 9. Good. 9 is in there. So I'm going to rewrite this. So I'm going to rewrite this as the square root of 2 over the square root of 45x. Now, if we focus on this part right here, Okay, so I've got the square root of 45x. I'm going to rewrite that as 9 times 5. And what do I need to make sure I don't forget? Good. I can take the square root of this 9 right here. What's the square root? Good. Okay, so what I'm going to do now is I've got the square root of 2 over the square root of 3 square root of 2 over 3 on the square root of 5x. So now all I need to do is rationalize the denominator with that 5x. Okay, so I'm going to multiply the denominator by the square root of 5x. And then what am I going to multiply the numerator by? The square root of 5x. Good. Okay, so in the numerator, everything in the numerator is inside a radical. So I'm going to get the square root of 10x inside the radical. Okay, we know that the square root of 5x times the square root of 5x is going to give us 5x. Okay, so my final answer to this is going to be the square root of 10x over 15x. I cannot cancel this. I cannot take a 5 out of both of these because it's very important. This is on the inside and this is on the outside, so I can't simplify any further. Okay? Those cannot be simplified any further because some of the numbers are on the inside of the radical, other numbers are on the outside. Okay, so this right here is my final answer right here. This is my final answer. Now, I want us to look at this one again in a little bit different way. Okay, we're going to look at this one in a different way. Let's say you decided to rewrite this as a square root of 2 over the square root of 45x, and you decided to rationalize the denominator before you decided to simplify it. And that's okay. You can do it that way. Okay? So I'm going to multiply by the square root of 45x, and then I'm going to multiply by the square root of 45x. Okay? So in the denominator, I end up with 45x in the denominator. Okay, in the numerator, what do I have? Square root of what? 90x. Okay, but what I need to do now is I've got to simplify that. So I'm going to be simplifying at some point. It doesn't matter when, but you're going to have to simplify. This is not your final answer because I can simplify that numerator. Now, I'm going to do this part over to the side. So I've got the square root of 90x. What's my perfect square factor in there? 9. It's still 9. So I'm going to have 9 times 10x. What's the square root of 9? Good. So I'm going to have 3 on the square root of 10x. So I have 3 on the square root of 10x over 45x. And can 3 and 45 simplify? Yes. 3 goes into 3 one time, 3 goes into 45, 15. So then my final answer here is the square root of 10x over 5x. 15x, thank you. Okay, so it doesn't matter which way you do it. I believe it's easier to go ahead and simplify this first, because you're going to have to simplify it at some point. I think it's easier to go ahead and simplify that first. Okay. Can we go to the next one? Okay. What is different about this? It's cubed. Okay, so we have to do cubed differently. We have to do cubed differently. Okay, so I'm going to rewrite this as the cubed root of 2 over the cubed root of 25. Okay? I would encourage you to break down that 25 into primes. Okay? So I've got the cubed root of 25, and that breaks down to 5 times 5. Okay? I need a set of how many? I need a set of 3. How many do I have? I only have 2. So what I'm going to do is I'm going to multiply this by 1 more 5, because I've got to have a set of 3. And once I have a set of 3, I can take the cubed root of that. So I'm going to multiply the denominator by the cubed root of 5. And if I do that, I have to multiply the numerator times the cubed root of 5. So now I end up with the cubed root of 10 in the numerator, because I've got the 2 and the 5. They're being multiplied, so I'm allowed to multiply those together because they're both under the radical. In the denominator, I end up with the cubed root of 5 times 5 times 5. And can I simplify this? Yes, because I've got a set of 3, and so I can write down the 5. So I've got the cubed root of 10 in the numerator, and then I've got 5 in the denominator. And that's my final answer. Remember, I can't do anything here and here because the 10 is inside the square root and the 5 is outside the square root. Yeah.
So, can you explain how you got, well, why did you multiply the 3 right with 5? Why
So-
did you add it on, like, I know we have to have 3, but.
So we only had 2, okay? So the cubed root of 25 simplifies to the cube root of 5. No, it's not as simplifying. It's just a rewrite, okay? So the cubed root of 25 is rewritten as the cubed root of 5 times 5. And I can't simplify that because I'm short a 5, okay? And this is my indicator right here. I've got to have a set of 3 5s. Okay, so I was short a 5. So when I multiply it by the cubed root of 5, I can rewrite that as the cubed root of 5 times 5 times 5. Okay, and so now I have 3 5s and I can pull one of them out. So I had to finish the cube. Think of it that way. I only had 2 5s. I needed 3, so I had to finish this cube.
It is okay for, just say if it was 5, or for the 5th group, we could add on 2 more 5s.
Correct.
Okay.
Correct. As long as you do the same thing to the numerator.
Okay.
Yeah, as long as you do that, you're good. You just have to do the same thing to the numerator.
Gotcha.
Good question. Okay. We ready to throw some variables in there again? Okay. Okay. So for this one, we're just going to do a rewrite. So I'm going to have the square root of 7x over the square root of 3y. Okay. And what do I need to get out of the denominator? What do I need to get out of the denominator? Good. So I'm going to multiply by the square root of 3y. Okay. If I multiply the bottom by the square root of 3y, I have to multiply the top by the square root of 3y. And this, the square root of 3y over the square root of 3y is the same thing as what? It's the same thing as 1. Okay, so what I'm multiplying here is 1. Square root of 3y over square root of 3y. Okay, same thing, 4 over 4. What's 4 over 4? X over x. Square root of 2 over square root of 2. 1. Square root of 3y over the square root of 3y. Okay, so now square root of 7x times the square root of 3y. I'm going to multiply my 7 and my 3 together because they're both inside the radical. And we're multiplying. And then I've got my x and my y. Okay. Then in the denominator, I'm left with the square root of 3 times the square root of 3. Square root of 3y times the square root of 3y. And that leaves me with 3y. Now, I cannot cancel these. Tell me why. Good. 1 is inside and 1 is outside. Okay, they have to both be in or both be out for me to be able to cancel those. Okay, they have to both be in or both be out. Okay. Okay. Now, we're going to do conjugates now. And we did a conjugate early, and it canceled out the two middle terms. So think about our difference of perfect squares. So now we're going to use conjugates to rationalize the denominator. All of the rationalizing of the denominator we've done so far, there's only been one term in the denominator. Now we're going to have two. Now we're going to have binomials in the denominator. And that's where our conjugates come into play. So, a conjugate. Many rational quotients have a sum or difference of terms in the denominator rather than a single radical. Okay? So, and this definitely comes into play in trig, right here. So, what that means is a single radical is like the square root of 2, square root of 5, square root of 6x. Okay? We are going to have something like, so this might be the square root of 2. What this means is we might have 3 minus the square root of 2. So we've been dealing with this, and now we need to learn how to deal with this. Okay? In that case, we need to multiply by the conjugate. So think difference of perfect squares. Difference of perfect squares. In that case, we need to multiply by the conjugate of the numerator of the denominator. We are focusing on the denominator. We're not rationalizing the numerator. We're rationalizing the denominator. The conjugate uses the same terms, but the opposite operation. Okay? Same terms, opposite operation. Okay? So that means if I've got 3 plus the square root of 2, I've got to multiply that times 3 minus the square root of 2. Okay? This right here has got to be opposite. That's got to be opposite. Okay. So let's see what this looks like. So this is what it looks like right here. We are rationalizing the denominator. Because we have two terms right here, we must rationalize by the conjugate. We must rationalize by the conjugate. So what I'm going to do is I am going to multiply the numerator and the denominator by the conjugate. So I'm going to have 2, but instead of plus, I'm going to have minus. Okay, and if I multiply the denominator by that, I have to multiply the numerator by it as well. Okay. Here, I'm going to distribute. Here, what am I going to have to do here? Okay, it's a binomial times a binomial. Correct. Good. So I'm going to FOIL. Okay. So I'm going to FOIL. Okay. So let's start in the numerator. I'm going to do my numerator off to the side. Okay. So I've got my 3. And I am multiplying that 2 minus the square root of 7. This is just my numerator. That's what I'm focusing on right here is my numerator. Okay. 3 times 2. Okay, and then minus 3 on the square root of 7. So I just took 3, multiplied it times 2, took 3 and multiplied it by negative square root of 7. So I am left with 6 minus 3 on the square root of 7 in the numerator. Okay, now I'm going to focus on this. I have to FOIL this. So I'm going to have 2 plus the square root of 7 2 minus square root of 7. Okay, so I am going to FOIL this. Okay, 2 times 2. Okay, that is going to be 4. Then I'm going to have 2 times negative 7, negative square root of 7. So that's going to be 2 times negative square root of 7. Then I have my inner terms, which is the square root of 7 times 2. Then I'm going to have minus square root of 7 times square root of 7. Okay. So we know that 2 times 2 is 4. Okay. This right here, what does that simplify to? Good. And we read that negative 2 on the square root of 7. What about right here? Positive 2 on the square root of 7. And we want that because what's going to happen right there between those two terms? Yeah, we're going to be able to cancel those. What's square root of 7 times square root of 7? So square root of 49. Okay. So square root of 7 times the square root of 7 is the square root of 49. But what's the square root of 49? Good. Okay. So now I've got 4. These two cancel. And then I'm left with negative 3. Because 4 minus 7 is negative 3. So I've got a 6 minus 3 on the square root of 7 over negative 3. Now, we are not done, and this can be simplified. And students make mistakes with this all the time. And even on your test, students made mistakes with this. So, let's go back and let's think about this right here. If I had 10b minus 5 over 15, okay, the only way to solve this correctly is to factor out of 5. That's the only way to solve this correctly. You've got to factor this first. So I'm going to factor out of 5, okay? So I have 5 times 2b minus what? 1. Then I have 15 in the denominator. So my 5 becomes 1 and my 15 becomes what? 3. So then my answer to this is going to be 2b minus 1 over 3. Okay? But I have to factor this. I've got to factor out the GCF. And students forget to do that. They just want to cancel this right here, and you can't. You can't do that. Okay? Here, what can I factor out of both of these? A 3. I can factor a 3 out of both of those. So I'm going to have 3 times what? Yeah, 2 minus the square root of 7. And if you had written a 1 right here, you would have been fine. Okay? Now, I can factor this. This 3 cancels. What am I left in the denominator? Not in the denominator. Negative 1. Okay, good. So I've got a negative 1 in the denominator I can't forget about. Okay, so then I've got 2 minus the square root of 7 over negative 1. Okay, am I allowed to take that negative 1 and move it to the numerator? Can I just move that negative to the numerator? I can. Okay, don't forget, if I've got negative 1/2, I can have negative 1 over 2 or 1 over negative 2. Okay, so don't forget. Now, what happens is students don't distribute that negative 1 once they get it there. That's what happens. Okay, so what you have to do is you've got to think of this -1 as -1 times 2 minus the square root of 7 over 1. So my final answer to this is going to be -2 plus the square root of 7. That's my final answer right there. Okay, so you have to be careful with that, and it takes practice. Okay, it takes practice. Okay, so that's my final answer right there. Okay. Now, we're going to do another one. But this one, we're going to have to FOIL the numerator, and we're going to have to FOIL the denominator. Okay. Is it okay for me to go to the next slide? Here we go. Okay, I am rationalizing the denominator. I am not rationalizing the numerator. The only thing I care about is this right here. It's fine if I've got radicals in the numerator. So this is the only thing I'm worried about right here. Okay? So I am going to figure out what I need to multiply by to rationalize the denominator. So I'm going to keep my square root of 2, and I'm going to keep my square root of 3. But instead of having a plus right here, what am I going to have? A minus. And if I multiply the denominator by that, I have to multiply the numerator. Okay? So I have to FOIL twice. I have to FOIL twice. So I am going to focus on the numerator first. And I'm going to do that off to the side. So I have the square root of 3 plus 2 times the square root of 2 minus the square root of 3. And I'm going to have to FOIL that. Okay? I have to FOIL that. So I've got square root of 3 times the square root of 2. I'm going to write that out. Then I've got the square root of 3 times negative square root of 3. Okay. Then I have 2 times the square root of 2. And then I have 2 times negative square root of 3. Okay. Square root of 3 times square root of 2 is what? Square root of 6. Okay. What is square root of 3 times negative square root of 3? Good, negative 3. Because we've got to keep our negative. Square root of 3 times square root of 3 is going to be 3. Then I've got plus 2 on the square root of 2. Okay. And then I have minus 2 on the square root of 3. Okay? Now, there is nothing in that numerator that I can combine. I have square root of 6, square root of 2, and square root of 3. Yes? Oh, this right here, this negative 3? Okay, so this is square root of 3 right here, and this is negative square root of 3. That's a great question, though. Okay, and then there's a negative right here, and that's where I got that negative. Yeah, but none of these can be simplified. And you might be like, did I make a mistake? Because I feel like some of those should be simplified. And you didn't. None of those can be simplified. So my numerator is going to be the square root of 6 minus 3 plus 2 on the square root of 2 minus 2 on the square root of 3. Okay, now I'm going to focus on the square root of 2 plus the square root of 3 times the square root of 2 minus the square root of 3. Okay, so this is what I'm doing here. Okay, and I'm going to FOIL. So I have the square root of 2 times the square root of 2. So that's the square root of 2 times the square root of 2. Then I have the square root of 2 times negative square root of 3. Okay, plus square root of 3 times square root of 2. And then I've got plus square root of 3 times negative square root of 3. Okay? Square root of 2 times square root of 2. What is that? Excellent. Okay? Then I've got negative square root of 2 times square root of 3. So that's going to be minus square root of what? Excellent. Okay, I've got positive square root of 3 times positive square root of 2. So what does that give you? Excellent. And then I've got minus square root of 3 times square root of 3. Good. Okay, these cancel because that's what we wanted to happen. And what's 2 minus 3? Good. So this one is also going to have a negative 1 in the denominator. Okay, I can move that negative 1 to the numerator, but what do I have to do? I must distribute it. So I've got to give that negative to everything in the numerator. Okay, got to give it to everything. So that's going to be negative square root of 6 plus 3 minus 2 on the square root of 2 plus 2 on the square root of 3. And we really cannot simplify any of that. This right here is our final answer. Okay? That is your final answer.